We can hear some noise.
Hi.
Hi.
Olin, Mal, Will. They're a good match here. Standardization, yeah. I was just thinking to the faculty and their students who's missing. It's an empty room. We should have a full room, by heaven's sake.
You said Amal, she's not here.
Well, she's grading the exam.
Right.
Jan's wounded.
And all her students are, Jan can't be here. That's about it. I say go for it.
Okay. There should have been a joke about Haskell and Matthias, but I couldn't think of a good one, so.
Oh, yeah, right.
It's my great pleasure to introduce Vitaly. He is a lecturer in the university in Russia. Now he's visiting in the Oregon with the Fulbright program. He works on the book on Haskell in depth, and it's going to be out about in a year. And he's now a member in the GHC steering committee and in Haskell Prime committee, and he's going to tell us about the way people do Haskell standardization. So I pass to Vitaly.
Can we ask a question, by the way?
Yeah.
There's only one implementation that matters. Why bother standardization?
We'll come to
Yeah,
that.
exactly.
We'll come to that, of course, of course. Yeah, so thank you very much. I'd like to start with a small piece of my own background in functional programming. And these are things that can be said in this room, particularly. Many years ago, like maybe 15 years or even earlier, I was learning Scheme, and I was reading the book Structure and Interpretation of Computer Programs. And of course I was using, at that time I think I was using Dr. Scheme as a tool for doing exercises in that book. And while I was going through that book, I was thinking that, well, something is wrong with this approach. So I was thinking
Yes.
that it's not programming. Like before that, I was studying Haskell or Fortran, some other languages, and they were doing something that is not programming, and I didn't like that. And then I was happy to find another book on the same topic, How to Design Programs, a book by Matthias. And then I realized that I was right when I was thinking that they are wrong. So thank you very much for that book.
One person will convince.
I think then after that I've made a mistake and I've chosen Haskell to work with. But I think that was my start in functional programming. So now I'm interested in functional programming, and in fact I'm not a very big Haskell fan. Of course I like that. I work with Haskell, but I like functional programming more. Like it's more important for me to make programming functional everywhere in every programming language. So that's what I'm doing with my students at my university. So while I'm using Haskell for teaching, I think that I teach functional programming, and I try to persuade my students to do functional programming in C++, in Java, in JavaScript, and in all other programming languages that they actually use. So, but in this talk I will speak about Haskell and the ways how we develop that language. And I'll start with a sort of an overview of Haskell development, just to give you a glimpse of what is going on and why should we care about development. So why there should be a process, why we need a committees, a whole bunch of committees in Haskell. So when we talk about programming in Haskell, we could imagine many topics. So for example, when we're talking about Haskell, we can have some tooling with a compiler and all other tools that we need for doing actual programming. Like we need continuous integration, we need some testing services, we need build services, stuff like that. So we need something to solve problems while developing programs. We could talk about libraries, like here we have one big repository of libraries in Haskell, which is called Package, and then there's another one. So there are some ways to get libraries at your machine. We could talk about programming style, because in Haskell we have lots of specific topics which relate to Haskell and which should be discussed while programming in Haskell. But in this talk I will concentrate on this part. So you see in this corner we have Haskell language itself, or I often say surface Haskell, so Haskell as we write it. And I will be interested in this Glasgow Haskell compiler. So the most important implementation of that programming language. So this is my scope in this talk, and I will talk nothing about that. And that's important thing that, by the way, we have a committee for libraries, and I'm not a member of that committee, so I know nothing about that. So they have their own processes and stuff like that. So what I will talk actually is about these two committees and what they do actually. So let's discuss what you see here. So we have a Haskell as a programming language, and we also have a compiler. And in that compiler we have also Haskell, but officially we should refer to it as GHC Haskell. So it's a Haskell as implemented in the GHC compiler. So and there is some difference between Haskell, and this Haskell is defined or described by Haskell report, and there is a difference. So it is not defined in the terms like a definition, like formal definition. It is pretty loosely described by that report. And then there is also GHC Haskell, so Haskell as implemented in the compiler, and there is a user's guide which describes that language too. So we have Haskell, and we have a lot of extensions which are described in this user's guide. And then we want to develop this language, and the main driving force for development is a community, so community efforts. So community wants to do this and that and that. And when we're speaking about community, in Haskell community specifically, there are these groups of users here. So we have commercial users, we have users who write open source software in Haskell, we have academic users, those people who do research with Haskell or in Haskell. There are a lot of different things there. We also have a lot of implementers, those who implement compiler, or those who implement those tools important for the ecosystem. And we also have teachers who teach Haskell. We have authors, guys who write book in Haskell. So I'm coming from the last group of the community members. So and all these groups, we have them, and they have absolutely different interests in Haskell development. So for example, if you are a teacher or book author doesn't matter, you'd like to have language stopped without any development at all. So like 10 years old Haskell, and that's fine. We don't need anything else, because you never teach those fancy things that they've added like a year ago or 2 weeks ago, and you don't want to hear about that. Well, your students maybe want to hear about that, but you don't want to talk about it. So these teachers and authors, they're quite conservative in the ways how they want the language to be developed. But commercial users, they want maximum. Sometimes they want the most new things. Yeah, question.
So Leonard Augustin has led, speaking of commercial, Leonard Augustin has not only led a commercial effort as Standard Charter to large Haskell programs, but he has created his own Haskell. With restrictions and call by value semantics in some places.
Right.
Do you consider, is it still a Haskell? Is it a part of the community, or is it not flowing into standardization?
I think of course they are part of the community, because there are interactions. Because if they try to do something interesting,
yeah, call by value Haskell.
So yeah, there may be some interesting implications into Haskell itself. Because, for example, in Haskell we had all strict annotations, exactly for doing something close to call by value semantics.
Yeah.
So and we didn't have that in the beginning. So of course we should see what is going on in the closed languages, like Haskell for GVM platform, ETA language. Of course there is always interaction, so we could consider them as a part of bigger community.
But they're not on the map in that sense. You've excluded them, right?
I think you can think about something in that group, maybe. So, yeah, but yeah, thank you for the question, and please feel free to stop me anytime whenever you have a question. It's no problem. Okay, so community wants to do something with Haskell, and then we have these three bodies for doing actual development. We have Haskell Language Committee, which is right now is called Haskell 2020 Language Committee. So, and its goal is to produce another Haskell report, Haskell 2020. And then there is also GHC Steering Committee, who is responsible for changes in the user visible behavior of the compiler and responsible in this version of Haskell, this implementation. And then there is also GHC team, and those are guys who are doing the actual job of implementing those features, or they have commit rights to the repo with GHC compiler. So these are three bodies, and then community one community or some member of the community want to do something with Haskell. They have to go through the processes. So it's not okay to just implement something in GHC team. Whenever you do something important, you have to pass through GHC Steering Committee. And it's only 2 years that we have this process, so it's quite new. We are still trying to get how to do things there. But we need that, because otherwise, when you have one important person in the community and he wants to do something, then before this committee, it was possible to do something and then degrade performance, like 50% for every program, compiling time performance, or something like that. So we don't want to have that. So we want to discuss thoroughly every new thing, every new addition, every change in the compiler, in order to get things right for all of our users. So that's what we need. Discuss everything, then implement that, and then we are good to go with this new addition. So that's why we need that committee, GHC Steering Committee. And this is another committee, and I will talk about that in the end of this talk. So this process is also maybe important, maybe not. That's the question. Yes?
Just for scale, how large are these committees and the GHC team?
So we have about we have 10 members of the GHC Steering Committee. We have about 20 in this committee, Haskell Language Committee. And in GHC team, I think they have about a dozen, maybe 2 dozens, something like that. So like but you know, like I'm a member of these two committees, and there are a bunch of people who are members of 2 of them. I think there are no members in 3 of these groups. So yeah, I think maybe 1, but maybe I don't know actually. Maybe that's interesting. I have to check that. But still,
the Simons?
Yeah. No. Simon is not in this committee, but he's in this, and he's of course a member of GHC. And that was actually when this committee was formed, and it was formed in 2016. There were 2 other committees, and Simon was a member of both of them. But then there is a rule that you are not allowed to be a member of the committee 3 times consecutively. So he had to step up, so there is no Simon in that committee. Maybe that's the reason for the problems we have there. So we'll come to that, hopefully.
Term limits for standardization.
All right. So, in order to talk about changes, yeah.
Excuse me.
Yeah.
Since you raised it, how long are the terms on these committees?
For this committee, it should be 4 years. And I think for this, it's 4 years, but it was formed individually with different terms. So there are 1-year members, and they were stepped up, so it's a little bit difficult. I think it's like U.S. Senate. So system, yeah.
Oh,
and I'm a member of this committee for 3 months only. So it's from the beginning of August. So there was a nomination phase, and then I was selected to be a member of that committee. So I wasn't there from the very beginning. Okay, so I'd like to discuss changes in Haskell. So how to change Haskell, but for doing that correctly, we have to discuss the process of compilation of Haskell programs. So this is the main part of compilation. Whenever you have one file in Haskell or surface Haskell, and how you compile that. So we need to understand this pipeline in order to talk about how to change that language. So, yep.
Does this belong under the Haskell standardization or the GHC standardization?
It's GHC.
Okay.
It's GHC. It's
Yeah.
compilation pipeline in Glasgow Haskell
Because I could
compiler.
imagine writing a Haskell bracket, #Haskell, completely different.
Exactly. That's GHC specifically. Thank you for this clarification. Yeah. So we have this GHC Haskell source code, and then the first thing you always do that with programming language, you parse it, and the result of that parse phase is an abstract syntax tree. In Haskell we call it HS-scene, and it's a tree data type with a lot of constructors, which resembles all parts of Haskell syntax, like from algebraic data types, functions, everything that we have in Haskell. And this abstract syntax tree survives through several stages. Like, for example, in renaming phase, you want to find every name, you want to identify every name which is used as the fully qualified name. So this is a function which comes from that module, from that library. So the renaming means just take, like, you have function head, but it's not just head, it's data.list.head from the base library, so that's the goal for renaming. And it's in the beginning of renaming you have HS-scene, Haskell syntax, abstract syntax tree, and in the end of renaming you have abstract syntax tree again, but it is parameterized with different identifiers. So we have so-called name, then we have reader name, so the name with the full information. So it's just the same tree with different identifiers. So that's a renaming. Then we are doing type checking, and as a result of type checking, or we could say type inference in Haskell, as a result of this phase we have again abstract syntax tree, which is parameterized by ID type, and ID is an expression with a full type information in there. So in that sense, so we have surface Haskell, and we've type checked it completely. Everything is type checked at this stage. And then we are doing the most important thing for the Haskell pipeline. We are desugaring that abstract syntax tree into so-called GHC core. GHC core here is some very moderate extension of system F, Girard system F. This letter C here means coercion, so it's system F with coercions. And we also have algebraic data types there, which is also an extension of system F. But if you look at it, so you'll see that it's really very small. We have about the three expressions in this language, they have only 8, maybe 9 constructors. So we have like 150 constructors in the surface Haskell in abstract syntax tree, but everything is desugared into this very small language with 9 constructors. So it's just lambda calculus with type information and like there are constructors for performance checking, like tick for doing performance analysis and stuff like that, but mainly it's just lambda calculus. And then you take this GHC core and you optimize it, and optimize means a huge loop of a lot of optimization that we have, and everything is done with this core. So you have core in the beginning, you have core in the end, and it is always changed during this stage of optimization. And then you have GHC core, and you have to evaluate it. You have to write evaluator. And in Haskell, we use spineless tagless G machine as a way to evaluate lambda calculus. At this stage, we just erase types, so it's just plain lambda calculus, but we need to do something with laziness, and spineless tagless G machine is responsible for that. So we use this language STG. It's a machine, or it's actually a language, and then we transform this language to so-called C minus minus. That's the last language here. C minus minus. It's like C, but it has no stack, so we use stack explicitly there. So, but GHC compiler is also a compiler for C minus minus programs. So you can write your program in C minus minus. It's quite tedious, I should say. And then you just compile it with GHC compiler. And then we can generate a bunch of different backends like LLVM. We can generate real C code to compile this program for the platforms where they don't have anything except for the C compiler. We can provide native code for many platforms like assembly code. So it goes here. So I'm not interested in that at all. So the important thing is here that we have several languages during this pipeline. We have Haskell, then abstract syntax tree, then STG, then GHC core, then STG, and then C minus minus. And then finally we have a result. So was there a question there? Yeah.
Yes, is the GHC core system FC, is that explicitly typed?
Yes.
So you have types
Explicitly
to erase.
typed.
Okay.
Yeah. We are doing type checking at this phase though. But we're using that for linting. So we want to check that everything is going on during optimizations. But it is explicitly type checked there. And well, of course, type inference there is undecidable. We know that. So it is explicitly type checked, but we check that every time after, in some modes, we check that after every iteration of the optimizations to make sure that everything goes right. So it's still type checked.
Mm-hmm.
And then we erase all those types during code generation. Yep.
Yeah, in the type check phase, if something is explicitly typed, do you do anything with those types?
Of course, they should be checked. I mean, in Surface language, if you have a function with a type,
Yeah.
well, we have to check that.
Mm-hmm.
So if there are no type, we have to infer that type.
Mm-hmm.
But it's actually, there is no distinction between these phases, type checking and type inference. We could see that information, but then we're still doing type inference, and then we check if the inferred type is the same as the type that was provided in the source code.
Mm-hmm. Okay.
So of course, this allows us to, so of course, if programmer says that this should have this type, then we should give it that type.
Mm-hmm.
But then we see we could infer something more general,
Mm-hmm.
and in that case we say, well, it's not that general, we'll use the type which was provided by the programmer.
Okay.
Could you say a little more about the connection to C minus minus? Because last time I looked, which was a long time ago,
Uh-huh.
I thought that JC was not using C minus minus, and I knew that Norman Ramsey was not actively working on it. So to hear today that you are actually using C minus minus is very interesting to me.
I think they use that. So at least there are phases, and you can look at it. So you can there is a flag for the compiler to output C minus minus code, and you just can output it and see whenever you use. So I think that's what we have now.
Okay.
So yeah, I think they actually use that. All right. So there is a pipeline, and now what does it mean to change language? So what could we do here? So the first thing is when we change something syntactical. And that's the easiest thing to change in Haskell. And here I tried to show that this change involves only changing in parsing. So if you just do something very small in syntax, then you don't have to change even abstract syntax tree. You just do something during parsing, and you produce the same nodes in the abstract syntax tree that we had before. That's the smallest change. But it's user visible change. Whenever you change syntax, users can see that. Another sort of a change is when you want to add new surface language feature. And now you have many options. If it's a small feature, that maybe type checking can be changed at this level. And sometimes you but in most of the cases, you want to stop here. You don't want to change GHC core. So if your change is that big that you need to change core, that's that very complicated thing. So we always say that thanks to Girard, we don't have to change the core very often. So like it was I think pretty stable for 10 years, and then it was changed once, and I think unfortunately 70% of changes in GHC core was made in last 5 years. That's not a very good thing. So
how many of those are related to dependent Haskell stuff?
not much yet.
Not much.
Well, some of them, but not much, because yeah, they're doing a very careful job in trying to figure out how to go with that. All right, so this arrow here. So what should be changed in order to introduce this new feature? Either parsing, or we have to change everything. I think it's very difficult to imagine some feature which would change something here. So normally changing language at that level doesn't need to change something at these stages. Yep.
Imagine Haskell before monads, before it became a dysfunctional language.
So it's 1993.
Yeah. So imagine introducing monads. And one of the monads that you want to make native is continuation monad, so that you can have fast access to the linear continuations. Wouldn't you have to go all the way down to generated code?
Oh yeah, I think so.
Right.
I think so.
So there are definitely changes around that could affect the entire pipeline. And
well,
you should never say never.
right. But yeah, as a teacher, I wanted to say never. I'm tempting to say that's.
Yes. Yeah. I know where you're coming from, but if you think about, you want a thread library.
Right.
Some of my students are using Haskell in my current course. They're struggling like crazy with the thread library, and they don't have certain access to certain operations that I have in Bragilevsky, because they're going to have to do the configurations.
Well, yeah.
So this is an example of something that you want to maybe think about, but the whole pipeline thing.
I don't want to think about that, sir. But that's.
Simon has a paper on that.
Oh, right. Okay. So these are changes to the language, but then we could also discuss changes to the implementation. So we can do anything in these things, in these levels. So we can do something with optimization, and that's I think the most often thing. We write something to make it faster. So we could change this. Like the most important recent addition was the creating LLVM backend for Haskell. So we compiled to intermediate representation of LLVM, and then we just use all that machinery again for optimization and generating code for many platforms. So we use that right now. So, but yeah.
Is it from GHC core to LLVM or from C minus?
No, it's from C minus minus. So it's all the way down and then LLVM. And it's actually this C minus minus is very close to LLVM, to the intermediate representations, or IR. I think they named that. So, but anyway, these changes to all that stages, it could affect something like this. And you see that error, if you change error message, that is something that is user visible. So even if you change something in generating code or in desugaring, then you have to be sure whether your change is user visible or not. So if it's not, well, that's fine. GHC team will handle that. So they can do changes there without consulting anyone. But if it is user visible, then we have to use this process of extending Haskell. So that's the question. And whenever we're discussing some changes, we have to say, is it user visible or not?
Wait, so what about, say there was like an optimization pass that produced wrong code, right? It actually introduced bugs in your programs.
Well,
and is fixing that bug something that they have to consult the steering?
Well, fixing bugs is, well, it depends.
Because that's user visible.
It depends, because, we had several examples of that. Like GHC team said, well, this change is important, so please go through proposal process. So that's possible, and we had many examples of that. So that's some people in JHC team, they decided, well, we have to discuss it a little bit more, even if it's bug fixing. So it depends, of course. Yeah.
Do you have a policy of backwards compatibility for bug fixing?
Well, I think it's not formal. So we could break backward compatibility. That's a problem, but not a big problem right now. So there is no policy which is written somehow.
So yeah, the reason I'm asking is we've come to a policy in the record world to even preserve some bugs for backwards compatibility.
I see. Yeah. So I don't think that we have something formal on that. Yep.
So there's a bug tracker, right? Is that owned by GHC team? Is
Yes,
it owned?
GHC team. That's
So
you mean
it's not owned by
track
the
bug
state.
tracker and track.
Okay.
Yeah, it's GHC team who's
Okay.
responsible for that.
Because it seems like if the GHC standards committee had some involvement, they could then say, okay, this bug, we think you should fix it.
That's
and that's an approval, right?
that's a different process.
Okay.
So we never say someone do something.
Okay.
That's not our goal.
Okay.
I'll talk about that later.
Okay.
So wrapping up with this part of my talk, there is a very good chapter in the book Architecture of Open Source Applications about GSC development. It is quite old, 2012, but there is a good phrase there, and I like it very much. And if you read it, please read it now. They say about using Haskell in research. So they are researchers, they are not compiler writers. So they do research, they use that for research. So research is everything for them. So, and it's strange that, well, they're not thinking about anything else apart from the research, at least in this chapter, in this phrase. So I think it's quite crucial here. So because we always have this problem, and once we have Haskell adopted in many companies, like if you want to write a blockchain application, you have no other way to go except for using Haskell right now, because you just do that in Haskell in many companies out there. So there are these things. So whenever it's about money, then you have to be more stable. You have to think about backward compatibility, of course. You have to do something about that. So it's not only about research right now, it's about industry either. So we have to think, and the committees, the goal of the committees, and the way how they are formed is just about that. There should be commercial users in those committees, so they should have their voice to say something about those changes.
How many commercial committee members do you have?
I think about
Standardization committee.
I think about maybe 2 or 3
Out
of 20.
And the GHC standards.
It's quite difficult because people are moving. Like our secretary Joachim Breitner, he was a research user, and then now he's writing something about blockchain, I think, in a company in
So he
Switzerland.
left Ken.
Yes, he left.
He's considered an industry person now.
Well, we don't have those labels there, but we can think about that.
Is Microsoft,
Mhm.
how does Microsoft relate to this committee?
I think Microsoft doesn't relate it at all.
I don't care.
I think so. And maybe that's a good thing.
Yeah.
Okay, so now I will tell you about the process. So how we do that technically. Okay, so we have GitHub organization, GHC proposals, with only one compiler. And here you can see the members of the committee. So currently we have 10 members of that GHC steering committee. And you can see all of them right here. So everything is open to the public. We have no secret communications deciding whether it is a good proposal or not. Everything is public. So you can follow this repo here, you're going to follow this repo here, you can follow this mailing list, you can read everything, so everything is public there. And in that committee, what we are doing is discussing something like this. This is a scope. This is what we want to discuss in the GHC steering committee. So the main thing here is user visible. So if it's syntactic change to this GHC Haskell, then we have to discuss it. If it's a change to behavior of the compiler, and that's what I was talking about, like changing information, error messages, something like that, is user visible, so we have to discuss that. And if you add something to the compiler, like a new flag for doing something interesting, then we have to discuss it either. But there is a process of deciding whether it is out of scope or in scope. So it's not very formal, actually. Sometimes you have to think, well, I don't know, what is it? Yep.
Sorry, so this is going a little bit back, but is this, so you're saying it's completely public, so does that mean everything is asynchronous? You only communicate as the steering committee
Exactly.
on these like proposals on GitHub?
There was a meeting at ICFP this year about one of the proposals, but it was at the lunchtime there. It was in the public place, so you would see that. And I joined that via some online service, so it was possible. But normally just mailing, so no actual meetings.
When did you adopt this policy of having public discussions on GitHub?
From the very beginning of that committee.
Which is like 2 years.
When is that? When was this committee run?
2 years.
Sorry, 3 years ago?
2 years. 2 years.
So were you heavily influenced by the Rust effort to?
Yes, they in the very beginning of the committee they were talking much about trust processes. Yeah, that's right.
Okay.
And I think now for
So
Haskell language committee they're trying to use the same system of RFCs, these
Yes.
requests. So yeah, so we've created something different, but we analyzed that a lot. That's for sure.
Okay, so you were inspired, but you didn't wholesale take over.
Exactly.
Do you know what you changed?
I think it's less formal here, but I can't say exactly. I can give examples.
We can
So I will talk about this process, and maybe if you are aware, then you can say that. So
I can say my question was related to his in a way, because like
Yes.
Rust had problems with, they used to have synchronous meetings for the committees prior to like some changes, and that was actually
I see.
hugely problematic.
Yeah, because we all were coming with different places, and it's
Right, that's where I came from.
Yeah.
And the Rust team is equally distributed over the world, as you are probably.
yeah, and we are
Compared to the Bay Area. at least.
nice, and we are too very distributed. Yeah.
Could you, since this is a recent committee, could you give an example of something that has gone through it since then?
Of course, I will do that. Of course, I will give you 3 examples, 3 case studies, how they work. All right, so this is what we are talking about in that committee. And then this is a proposal template. So in order to make a proposal, you have to come up with these things. So the proposal starts with motivation, why we need this thing, and that's quite important. We don't want to do something just for doing that. We need this motivation. Then you have to describe what should be changed in the second section, proposed change specification. Then you want to analyze things, how this new feature or this change interacts with other Haskell features that we have now, how it is affected. Like there is a well-known example of two features in Haskell. It's a generalized new type deriving and coercions. When they were introduced, in a year or so, they found a bug in a compiler that it was possible to look at the bool value as an integer value.
Oh.
So, and it was a bug in the type system. And it was a result of these 2 features that were added without too much research, and together they created this bug. It was awful for type system, for static typing. So
Could be the sec fault.
well, yeah, I think yes. It's
Cool.
I don't think so. Okay, so it's difficult, and of course it's not something that you can come up quickly. So these interactions, they can be hidden somehow, but the goal is to find out what is going on. So the goal is to discuss what could go wrong with that new feature. So then you have to say about costs. So it can be compilation time degrading or something else. So you have to think about that. Of course, there could be drawbacks. So it's not always the case that we're doing good thing without any problems. We have always problems. So we have to state that clearly, whether we are ready to have those drawbacks with this new feature or not. Then there could be alternatives. And the first alternative usually is do nothing. It's pretty good alternative. And then there could be other ways to solve the same problem. And here we're talking about that motivation. So maybe we could get to that without implementing this change, but there are other options, so we have to discuss it here. There could be unresolved questions, something that will be resolved later, so that's perfectly fine. So it's not a closed document. It's actually a document which describes our intentions, or intentions of the author of the proposal. We want to do that. Now let's discuss this. So we could change this all the time. So, but it's a template. So whenever you write a proposal, you write it in this way. And then there could be implementation plan. But implementation is something which is unrelated to the GHC steering committee. We're not talking about implementation in most of the cases. So there could be a plan, like I like this plan. My students will implement that in a month. So that's what we normally have, or maybe that's a little bit optimistic all the time.
They don't actually describe like proposed mechanics of implementing it, like
sometimes. Well, it is possible, but it's okay not to discuss that here, because it's not our goal. Yeah.
Like, what is the format and how well it should be worked through? Is it just a text or
It's
a published paper?
It's RST format. It's something like Markdown. It's some form of that.
So you don't need published paper on costs and drawbacks to
No.
make a proposal.
No. But
Okay.
well, very often you have that paper before this proposal. So when you write paper, you don't have to think about things like that. Well, usually. But then when you want to implement that in a real compiler, well, that's a question. So I think I'll show you an example. Well, having paper is not enough. Because when you implement something, well, you don't believe in that paper. So all that bullshit that
Well, there
they
are groups that publish papers after implementing and running it through 1,000 users, right? Sorry.
Who could that be?
Yeah, I think that's not the case with the Haskell. That's what they do in Haskell.
Proposals ever come forward with like an example implementation, so you can test it out or something like that, or is this more?
Yeah, it's possible. So sometimes we have several proposals with the link to the GitHub fork of GHC compiler, so you can check out that branch and see what is going on. But it's not required here.
GHC itself isn't actually on GitHub, right?
Well, there is a mirror on GitHub.
Yeah, but the main
so you can
development is not
fork
there.
it, but you cannot develop through GitHub, at least now. So things may change in the near future because there is a big discussion, but they don't want to use GitHub. Maybe they will use GitLab instead. So
Really?
there is a.
Microsoft owns both, right?
I'm not sure about GitLab.
GitLab is Google.
So Microsoft owns the hardware that GitLab is running on.
Yeah, no, but they're moving again to GCE because Google is the main investor.
Oh.
So we were using Fabricator and other tools. There's a tool which was developed in Facebook, I think, and it's quite outdated right now, so it's not very convenient. But we use that, and there is actually a whole bunch of tools that we have to use in order to provide patches to the GHC, and it's not very convenient. And there is a discussion, but it's a long story, so it's.
But so why are proposals on GitHub if Haskell development is not on GitHub?
Because it was convenient to do that. Because we have many examples. We have also Ruby things, what they do in Ruby, and they use GitHub for that.
Yeah, but all of those languages also use GitHub.
Yeah, but well, it's pretty independent. So we are not talking about implementation. So we just, if you have a link to somewhere, then that's fine. Okay, so this is a proposal, and the author should write that proposal. And the process is as follows. So the first stage is when the author drafts a proposal. It's a real draft. And so it's technically, it's just a fork of this GHC repo. And then when the draft is ready, this proposal should be submitted. And submission means a pull request against this proposal. And all discussion of that proposal goes within that pull request. So there are many comments there. So, and that's a discussion by the wider community. So so if you want to discuss that proposal, you are free to go. So it's open, so you can leave your comment, you can say something. And this is a process when the author is able to refine this proposal. If there are some issues with that, well, I'll change this, we can change that. So the author changes all that stuff according to the discussion. And then when there is a point that when author decides that it is ready, so the next stage here is bringing proposal before the committee. So our author should write something in one of the comments. Dear committee, please review this proposal. And this is the stage where we start our work, exactly at this stage. So we have a secretary. Right now, secretary of the committee is Joachim Breitner. So secretary proposes a shepherd. It's funny that in the original scenario, we had this phrase that committee member volunteers to shepherd this proposal. But I never saw something like that. So it's always the case, like secretary is writing a mail in the mailing list. So please, like Vitaly, for me, shepherd this proposal. And then I say, okay. So that's how it works. So so there is a shepherd for this review, and then the job of a shepherd is to provide a recommendation. So, so we give a recommendation, and then we need a consensus within the committee. So these 10 members of the committee, they all should agree that this is a good thing. And recommendation is something like that. This is a proposal. It is about this and that, and I think it is a good thing to have, so let's accept it. So that's a recommendation. And we always say that silence is understood as agreement. If no one complains, then well, that's fine. And it's usually 2 or 3 weeks. But if someone is, well, you can write, committee member could say something, well, I'm okay with that. So, or if he's not okay, then, well, there is some discussion. And this generating a consensus is sometimes a huge problem. We could ask author to tweak something small, or we could discuss these things within the committee in that mailing list. But then there is also a process of voting. But for these 3 months, and I think before that, we try not to have voting on that, because it's something that we don't like. Yeah.
So there was a community in step 3.
Mm-hmm.
Can that community participate in the discussion of the committees and the committee is public?
Well, technically it is possible because this mailing list is public, so you can do that.
And have you seen that?
No. Okay. So maybe once, but it was small comments or something. So, but it's
technically possible. The community lobbies members for agreement or consent, whatever voting. Okay.
Well, yeah, it is possible, of course, yeah.
So kind of the reverse of that then, it sounds like the wider changes happen early on, like in steps 1 through 3. So are committee members ever involved in the community discussion early on?
Of course, yeah. Because many of us just comment on those proposals because we don't want to get something bad under review. So ideally, we have this proposal and we all agree, and it is just accepted. So So yeah, Simons, they are two co-chairs, Simon Peyton Johnson, Simon Marlowe. They are co-chairs of GHC steering committee, Simon and Simon, and they have veto right. So if they don't like voting results, they can, but I think they never executed that right yet.
So I'm a bit confused. You're saying you're generating consensus, but then you're saying at the end you vote.
So
that sounds like you're not generating consensus.
Exactly. So we have the process of voting, but we don't want to use it.
You have sort of a three-stage process, is that right? First, you try to get consensus. Failing that, we vote. And then at the end of all of this, the Simons get to veto, which we hope that they never do. They rarely do.
The United Nations, right? And it's designed by the Security Council.
It all seems very reasonable.
Well, yeah. So we try to do consensus, and I think that's the case in the most of proposals. So that's what we want to have.
The problem with requiring consensus is that you can get one person who is passionately dedicated to this is an evil idea over my dead body.
But
and then,
hold on. This is very distinct from, you missed the beginning, this is not the same as in the scheme consensus model in the 90s.
I wasn't naming any names, but...
and we'll comment on that. But,
it could be jinxed, we could say.
Yes, jinx is exactly the right word. For those of you, Jinx was a member of the committee and he was very dead body.
Yeah, he was a smart guy and a good guy. He just had an aesthetic and a taste that made him passionately, religiously opposed to many proposals that others wanted to push forward, and everything completely deadlocked.
But it's different here. It's 20 or so select members, or 10 select members of the committee. It's not the whole community.
Yeah.
And they're elected.
And they're elected, exactly.
Yeah, but they're elected in a
consensus manner.
Yeah, but
I don't know how we elect new members. This is a private thing, by the way.
How did you become a member?
My point is, this is a very good mechanism. This mechanism here says consensus is a good thing. You should strive to get it.
Right.
And if you can't get it, there's a mechanism here to move forward anyway.
Yeah. So
That's
just to
all
keep
good.
moving, we want to keep moving, and so otherwise we could have just one proposal accepted and that's it. So that's not what we want here. All right. So this is this stage, and then finally, the committee decides what to do, and we have these options. We can reject a proposal, we can accept it, or we can pass it back to the author. So if this proposal requires some changes, well, we say, well, please revise it. And then it starts over, so revising and then bringing under review again. So this is our process. It's pretty formal. It is described in the GHC proposals repo, so it's I just reformulate some stages, but it's pretty what we have there. All right, and then this is an important thing to have. So once a proposal is accepted, someone should implement it. But we are not thinking about that. And then, this is the most crucial thing. So if we've accepted the proposal, then the implementation will be accepted into GHC. So we are okay with that. Although there is this last part. So that's the responsibility of GHC team.
Yeah, because wait a minute, you said that you can accept a proposal without there being an implementation.
Of course, right.
So it could come in implementation and it could be awful.
Yeah.
Okay.
Of course. And then we don't limit who is responsible for implementation. Technically, it could be anybody. If you see that accepted proposal and there are no people who work on that, well, just try to implement it. That's it. And then this GHC team decide is it well engineered or not. And that's their own thing. I know nothing about that. So that's the goal of the committee. Discuss a proposal, accept it, and then try to implement it. All right, and now, so this is basic stats of that proposal. So there were 136 submitted proposals there, and we've accepted 41 by this moment for 2 years. And some of the authors, they have several proposals, some of them have only one. We've rejected only 7, but that means that most of the proposals, they were not discussed within the committee. So they didn't reach these last phases with the committee.
7. Those 7 did not reach.
No, these are reached, so we've rejected them.
Everything else did.
So yeah, so everything else, so you see, like, these numbers, you cannot sum up them to something meaningful, because some of them are just thrown away by their authors, and that's fine. So they can.
In particular, the numbers below the 136 do not add up to 136. Right.
Yeah, exactly. So that's because there are something that those pull requests, they can be closed if you don't want to discuss that. So you just don't think anymore that it is a good idea.
Were the 7 rejected unanimously?
Of course, no. Of course, no. They are rejected publicly and with the reasons. So in that case, Shepard.
Were all the people voting? Did they all have consensus to reject those proposals?
Yes.
Okay.
And there is a reason for, and it's usually pretty understandable. So it's a reason why we reject that. So we don't want this thing in the GHC.
Could there be a version 2 which is better, or it's something completely that bad that you cannot refine?
Yeah, so it's something like that. So they are really something that we don't want to have.
So a rejection is like, this will never happen for GHC?
No, of course no. We never say never. No, I was instructed to say that.
But is that like the kind of signal that a rejection is supposed to mean? As opposed to,
yes,
this is not the right time for this feature?
Well, right. Well, maybe that's not that. No, when we're talking about try time, we have these so-called dormant proposals. We have 17 of them. And this is something that we don't know what to do with them. So they are dormant, meaning, they're sleeping somewhere in our repo. So they're not accepted, they're not rejected. They need more discussion maybe, but sometimes this discussion is almost over because we don't know what to do with that. So we have something like that. And maybe that's the something for the future. Whenever someone come up with a great idea of doing something with this stuff, then that's fine, then we can.
So there's no fuse on a proposal?
No. So we can leave it forever there.
Where is linear Haskell here?
Linear Haskell is not here, technically.
Okay.
That's a difficult case. I'll talk about that. So now I will quickly give you several case studies about this. I've picked up 3 proposals to show you. The first proposal is deriving vir. So that's what it's about. There is a paper, Haskell Symposium 2018, about this deriving vir extension. So the idea is as follows. So you define something like this. So you don't know Haskell, that's fine. So I will give you a broader idea about that. So you define some code, and then this code is a pattern, is an example of generating other code. So these type constructors here, these function calls, this pattern matching here, it's an example. And then this extension is able to derive the same implementation as this one for other types. So we say, please do the same thing as here. So we give a pattern for deriving, and then we derive that. This paper is about that. So this is a pretty good thing. So we don't have to write manually many instances if they look the same. And it's always the case when you're like deriving monoids, semigroups, or something simple. And it's really a very good paper. And it works, and it was implemented before coming to the committee in some fork of GHC. And so this is moderately small change because, well, we don't have to go to the GHC core, but we have to extend syntax. So it's we have to change this derivation mechanism. We're able to derive more code. Then we have to type check some generated code, and there was some work about that. So it's not just syntactic change, but it's quite moderate. And it was submitted in April 12th. And then you see here 11 days for community discussion, because everything was pretty clear there. So, and then it took us a month to accept it. So that's pretty quick. And it was our 23rd proposal. And now we have 41 accepted, so you can compute the difference.
All right. How many are implemented of the accepted proposals? You didn't give us that number.
I don't know this. Don't know this statistic, but I think it's about half of them. So there are many unimplemented proposals, and even proposals without any idea on implementing them. So about a half. I think something like that. All right, that was first use case. Very simple. And the shepherd for that committee was secretary himself, Joachim Breitner. And he said that, well, it's a good thing to be a secretary, to pick so nice proposals to shepherd when everybody's agree in a minute. So it was very, very funny idea. And another case study is linear types. And that's an absolutely different example. So again, it started with a paper, Popple paper 2018. So it's last winter. So this is a paper, and the change is as follows. So they wanted to introduce so-called linear functions. And this is like very loose definition of that. It's if a result of a function is consumed exactly once, then argument is also consumed exactly once. That's it. So there were many discussions about this definition, whether it's suitable or not. And then if we have functions, linear functions, whether they are consumed once or not, then we have the so-called multiplicity in that case. So it can be either 1 or omega for anything except that 1. And we don't want to write functions with both of them. And then that means that we need multiplicity polymorphism. So we want to write function which is able to work as a linear function and as a not linear function. So this is an idea of this proposal. And technically, it's not about linear types. It's about linear function types. So linear arrows, some says. So, and the important thing is that it's about writing good interfaces, and it's not about performance. So we're not trying to make linear Haskell performant. It's just writing safe interfaces for that. So that's an idea. And this is a big thing. So we have to change JSC core. And there are many interactions. So it's a very difficult thing to implement, but we're not talking about implementation. So here we're talking about specification. So we had a paper already. It was reviewed and it was accepted to Popple. So it should be a nice paper.
That's great.
So the timeline was as follows. So the first draft we've got in November 9. It was before that paper. And then there were like several thousands of comments there. And then there was second draft, completely rewritten. So again, it's okay to write a paper, but it's not okay to implement this stuff there. And then it was shepherded by Richard Eisenberg for quite a long time, like several months. And then this proposal was conditionally accepted. So there was a meeting at ICFP, offline meeting, especially for discussing this particular proposal. We were trying to decide what to do with it. Because, well, it is not ready for implementation, for inclusion into GHC. So this conditional acceptance was, it was created exactly for this proposal. And that means something like this. We as a committee, we don't think that it is accepted. So, but it's a nice thing to have. So we accept it conditionally. And of course the offer says everywhere that it was accepted. But for us, so it's just something like we want it to be grace here. No. So
what is the condition?
There are conditions, and that's a very important thing, actually. So these are conditions. We have 6 of them. They were clearly formulated. So we have to make sure that the implementation here, that it follows these conditions, and then it's we're ready to accept it finally. So what does it mean? The extension is pay as you go. That's a formula from Simon Peyton-Jones. He suggested that. Means if you don't use that extension, then you shouldn't see anything. So you shouldn't have any idea that something's going on. Like well, you have to change map function, and its type changed, and error messages could change. But you have to make sure that you will not see anything like that if you don't use it. There are no clear syntax yet, so we have to talk about that. So there should be soundness. It looks like right now, the theory in the paper, it is sound. I know that there are many definitions of soundness actually, but we want to make sure that it will be good whenever they change something there. So that's one of the conditions. And then this proposal, the changes to the core should be explicitly described in this special document. We have that document in the GHC, the definition of core, and it's pretty formal with all those type checking rules and everything as we usually do in programming language semantics. So, and then when you use that, the price should be reasonable. There should be no twice compilation time, for example. And then there is a problem with the base library. So if you want many functions to be linearly polymorphic, so then you want to make sure that it will not affect something. So there should be some work done with the library. But that's a little bit different from the scope of the committee. Yeah.
So the first time I heard pay-as-you-go slogan was 1986 in a talk by Kent Dybvig. And about 8 weeks ago, he publicly repudiated this phrase as saying it was, don't remind me of it, it was a bad idea. So he gave a talk on 35 years of Shea scheme at the RecordCon place. So Will is going to contribute in a moment, but he basically said, you know, it may be a good idea in some ways. Initially, when I wrote my dissertation, the first X versions of Shea scheme, but right now I no longer believe that this is actually a really doable thing for way forward. How firmly do you believe as a committee that this is the right way to exclude or accept features?
Well, I formulated.
Or is it just gone for that one?
There was a funny phrase there. Well, it's okay if it's 2% slower. So something like that. So
number 5 and 1 go together.
Number 5, it's these two actually. They are soft conditions. So 4 first they are hard conditions. So we have to make sure that that's fine. But with these two, well, we have to discuss something.
So
yeah.
I think it's important to realize that what Kent Dybvig meant by pay-as-you-go is different from what is meant here. Kent Dybvig's interpretation of pay-as-you-go was that he never made a change to the compiler that failed to improve the compiler. He never made a change to the compiler that degraded the compiler's speed. And that was a very weird definition of pay-as-you-go, but that was Kent Dybvig's definition.
That is correct. He was on the last two only. Type inference doesn't exist really in Shea scheme. Error messages he didn't care much. You're right. I agree. There's a very so.
Well, no, but the important what I'm getting at is that this is pay-as-you-go for everybody, whereas for Kent Dybvig, pay-as-you-go only applied to him, and not only did it only apply to him, but it applied to only this one piece of software he wrote. That performance could be degraded or whatever for other software, but as long as it sped up the compiler, it counted as pay-as-you-go.
So Will, this is my understanding. The last two things in parentheses are number bullet 1. That's what I understand about this bullet. Maybe I misunderstood. That's how I interpreted this slogan.
The things in parentheses, what?
You mean
performance, and I believe that's off the GHG compiler.
Wait, but I think what Vitaly was saying was that it's if you don't use any of the linear features, then you get the same.
And the way you measure it is in the compiler, with the compile time performance and the runtime performance of self-application.
Yeah.
Right.
But if you use
that's what I thought was going.
Yeah. So if you use that, then that's the item 5 is for that. Yeah, it's possible to slow down. That's fine.
That philosophy has been used by a number of people, a number of implementers in the scheme community, but I don't think that's what Kent Dybvig meant by that.
Okay.
So I think Kent Dybvig is like the worst example that you could pick.
Okay. Well, he repudiated it. He said no, it's a bad idea. His version.
Yeah, but that's because he had a really weird notion of what it meant.
Okay. Okay.
Here, let me clarify this by giving a good example. One of the goals for a lot of implementations is that first-class continuations are pay-as-you-go in the sense that there should be essentially zero overhead unless you use them. If you use them, there might be a big price to pay. But as long as you're not using them, you're going to get the same performance as if they weren't there. And so that's an example of a pay-as-you-go philosophy that's been common among a bunch of implementers. Not everybody, of course.
Yeah.
But that I think is what's being meant here. I could be wrong. Correct me if I'm wrong.
Well, I think it's close to that. So, but we're talking about this particular proposal. This is a condition for this proposal,
Right. Yeah.
because it's a big thing actually. So we want to make sure that it's the problem with this proposal is that it makes harder for everybody. If you just change the type of the function, and everyone uses functions, so it's a big thing. So you don't want to affect all of the community. So it's so that's why we have this condition here. But I don't know whether it will work or not. We'll see. So it's just 22nd of October. So it was a month ago. So we'll see how things are going on with that. All right, and the third case study is about dependent types. Another thing here. So the idea, well, just using this vector example, and everyone maybe know about that. So we want to have data types which depends on types and on values. So that's what we want to do. And then this would allow us to write functions like this, where you're zipping two vectors of the same length, and you have to provide these two lines, whether they are both nils, so they're both empty, and they have the same number of elements. And you don't have to write all other things here, all other clauses, because they are impossible thanks to this. And then this is also says about erasing. So if you use for all quantifier, then you can erase numbers and types during evaluation of that expression, because you don't need them anymore. Everything was type checked. So that's dependent types. And what we have now about that. So
is that a completely special case for numbers? Like, is it just you can erase numbers from types?
No. It's just well, usually you erase types, and here you also can erase numbers. And if you say that types and terms are the same thing, then you have no type erasure. You have something erasable and something non-erasable.
Yeah, right.
So that's why, and they use for that they use different quantifiers. So this for all quantifier should mean erasable thing. So it's not about type or term. So we have a key developer, Richard Eisenberg, and this dependent Haskell is developed somehow for 5 years now, and there was a big extension to the compiler, type and type, which introduced awful thing from the point of view of set theory. So we've got a paradox there, but we're fine with that because, well, we have non-termination, so that's not a big problem for us. So, and this extension never had a real discussion. So it was before the committee was formed. So it was a big thing, and it was implemented. But now we have many small proposals in this line. Some of them were accepted, some of them are under discussion or community discussion right now. But they are very small, they're very technical, and they go quite quickly. Because, well, it's very hard to talk about them. Well, they are difficult, they are technical. There are not too much people in the community who are able to say something about them. So Eisenberg struggles for non-intrusiveness. He wants to do things without interfering something else. So, and it looks like this is a strategy. So if you have one big proposal for dependent types, then I think that it would be very difficult to go through the committee. But if you have many small ones, well, maybe you can do that. It looks like a strategy to me. I'm not sure whether Richard thinks about that or not.
It's a political campaign.
I think it's close to that. From my point of view, it's something like that.
But its efficacy is rooted in the fact that nobody understands what he's proposing, except for like
somebody understands.
Yeah, like Simon understands.
Stephanie understands the thing.
Yeah, and Stephanie understands.
Yeah, so that's
advisor.
Okay, well, we'll see. We'll see. Maybe.
So,
yeah, but you know, some of these proposals they were drafted by other people, not Richard.
Oh, okay.
And Richard, of course, he's always shepherding things like that.
Well, there's like students he's advising now?
No, there are some independent people trying to work on this.
Yeah.
So we had that.
Yes.
All right. So So the problem with this is that we have to change everything. Just that's an example. So if you have these erasables, that means that you have to change even code generation. So it goes all the way down. So and this is a roadmap here. So there was a blog course in this 2016, 2 years ago, and in that blog post there was a comment from Richard, which is pretty fresh, that with something like this. So I think we'll have another 100 of proposals during these next 2 years to get this done. So we'll see. So that was the third case study, and that's it about GHC steering committee and proposals and the process. And I will say, yeah, I know that it's can be quite late now. So Haskell 2020. So of course the first question is, do we really need a Haskell standard? And there are no clear answer to that. So if you have just one compiler, of course you have 3 or 4, but they are very small, they are very academic, nobody uses them except for their authors. So, but it's a question. So there is no clear answer. I will try to give one answer, at least one answer for that, but right now it's an open question. And maybe that's the reason that we're not doing a lot of things in that process. So the goal is as follows. So we want to describe something stable, something useful, and I mean GHC extensions. So in GHC, they have many extensions, like 200 of them. And we want to incorporate them into Haskell language so that the user don't have to enable those extensions. So, and there are 2 questions. How to choose things? What should be described by the Haskell report? So something that is used very often, something that is a good thing to have, maybe something that we need very much. So these are questions, and they are open actually. And another problem is how to describe those things in the text of the report. So we have implementation in the compiler. That's one way to describe that. There is a paper at some conference. That's another one. But where should be a standard text of the report? So where should we provide the algorithms for type checking, generalized abstract data types, for example? So we don't know that, and it's a big question. How to describe this, not formally, informally, but still in the text of that report. So that's the problem. Then we could also remove something. So and again we have to decide what to remove. And one point which is important for me is setting this stability. So we would like to have Haskell as defined by Haskell 2020 report. And then when you write a book on Haskell, you say, well, I rely on that. When you teach Haskell, I rely on that Haskell 2020. And it should be a way in a compiler to say, please compile this code as described in Haskell 2020. That's why we may need that standard. So it's a good thing to have something like that. All right, so that's but again, the overall question is still open. So we're not talking in that committee, we should not talk about new features. Only what we already have for dozen of years, for example. So that's what we need that committee for. And oh, sorry.
Only what we already have in GHC, or only what we already have in GHC and these academic?
I think in GHC.
Okay.
I think because that's the only way to get something well tested. Because otherwise it's not we cannot analyze.
Well, no, that you're interpreting my question differently. So when you say a well-tested feature, you mean well-tested in GHC, and even if no other implementation has ever implemented it.
Right. So that's enough for us. But it's difficult to get well-tested feature in some other compiler because nobody uses them.
Right, but there is some advantage to seeing whether the feature is feasible to implement in other systems. That instead of being so GHC dependent that it basically locks everybody else out.
Maybe that's our problem. But I think that GHC is the main compiler for us.
Sure.
But of course we can look there. But
scheme for 45 years, right? So.
I see.
C, yes,
We have
exactly.
lots of scheme implementations,
A lot.
or
Yeah, I
at least
know, yeah.
comparatively lots.
Right.
Maybe for
More than
Haskell that ship has already sailed though.
Yeah, could be.
Okay, so and so this committee was formed.
So,
in-
okay, can we go back?
Yeah.
So, I mean, we have a very minor situation like this in the Racket world. There's two alternative Racket implementations, one that Amazon did on JVM and one that is living on PyPy. And I'm thinking that what you're describing here isn't actually necessary until you have a situation that will have to govern or cope with, right?
Mhm.
When you have 70 implementations of a language and 6 major ones that try to have portable programs.
Yeah, that's
In
what we
our
have
case,
in C++.
None of us want to support programs from Amazon to here or vice versa, except for core program libraries, right?
Mhm.
Same for development implementation that is on pipeline, right? So, what's the so the real question is, you've got the question of what the goal could be,
Mhm.
but what goal is there if you have only one implementation?
Well, yeah, that's why it's an open question. So that's very unusual for programming languages right now. So if you have only one implementation, but I mean that this point is crucial for me. But of course, it's so that's why that explains that we're doing almost nothing.
Okay,
Because,
never mind then.
because we are not we don't know what to do, and we don't know how to do, and we don't know whether we should do that at all. So that's the problem.
You're
So-
doing nothing and you're not sure whether you should be doing nothing.
But you know it's a very good thing to say. Well, I'm a member of Haskell 2020 committee, and I use that all the time for the 2 years from the.
It's for his dean,
Sure.
right downstairs.
I understand that.
More bullets on the CV.
Yeah, right. It's very they look very well. I think.
Bullets. Don't join the committee. You have to do nothing for that.
Exactly. So that's why I'm using that. So this Monday there was one proposal that was accepted, some change to the text of the report. It was pretty technical, and the proposal was just to remove one phrase from the report. And it's absolutely nonsensical, so nothing interesting was there. But we were trying to test our process, and this process is much closer to what they do in Rust actually. So the process for Haskell language committee. But I'm not talking. I don't want to talk much about that because, well, really we're not doing anything yet. So we have to do more. And if we do, then maybe it's possible to say. And then we have no clear leader, and that's important thing also. So well, just no one say what to do, and that's another problem. But everything is still open. You can follow these links, and you will see that we have some discussions and like that. Yeah.
Where did the text come from of the report? Because we currently have something.
We're taking Haskell 2010 report.
Mm.
So it was edited by Simon Marlowe, by one of other committees, previous committees. So we are changing it. That's the idea. All right, so that's it, and thank you very much. I think we have still 6 minutes before lunch.
Yeah. So I've seen many people who teach, trying to start teaching Haskell as the first language, and they all struggle because Haskell is quite complex, especially in terms of errors, and some of them try to hack Haskell and do some simpler version. So do you think it could be one of the goals to have some simpler version of Haskell as a standard for, say, teaching, and another Haskell for industry or something like that?
I don't think that it's a good thing, and the problem is that the problem is the motivation of the students. So it's very difficult to persuade students to learn something which they will never use in the industry. So, well, of course, we are doing things like that all the time, but and I think in Haskell that's something that we don't need. So, like Eric Mayer, he was complaining a lot about some recent changes in GHC compiler when we made all list functions not over list but over foldable type class, and this we've changed a lot of type annotations for the most simplest functions. So there was a big problem, and he said that, well, I'm not using GHC anymore. I will take one old implementation of Haskell. It's an interpreter. It's quite old, very outdated, but it's fine to teach Haskell. So we could say that we have this Haskell. So it's small Haskell, very small one. Well, you can teach things like monads there, or lists, or something, abstract data types. So we have something like that, but personally, I don't want to use that because I want to be, well, along the lines of the development. So maybe I would like to teach linear types soon. Maybe I would. So then it's a good idea to have something new.
But maybe not for the first year students, right?
Well, why not? Well, it depends on how you teach that. Of course, you can do everything with freshmen. You can do whatever you like, but then you'll see what's going on then, whether they complain or not. Yeah.
So I wonder, but that, I mean, isn't that just a matter of like the choice of base? And I mean, I saw a lot of people complaining about that, and I didn't understand because you could just like replace Prelude with all the concrete list implementation.
The problem, yeah, that's right. The problem is that it's very difficult to install all that stuff in students' machine.
But they have to install HUDs.
Yeah, but that's just one point. Yeah. And it's very difficult to install something like GHC 6.12 right now with modern OS distributions, and then there will be a lot of problems with interaction with other systems. So usually it's easy to install the latest version, and it can be problematic to do that. And that's an important thing. So if you're learning programming, you don't want to have problems with installing your software, because it can be a very big problem for students, for freshmen. They have to learn a lot of new things, and now they struggle with installing them. So it's should not going to work, I think. That could work, but it's another difficulty here.
You mentioned there were some differences between the GHC steering committee process and the Rust process. Are there any particular differences that you found have improved the Haskell or the GHC
I personally,
process?
I don't know how to answer that. So I'm not that aware of Rust process. So I don't know that.
So the entire steering committee voting part does not exist in Rust at all.
I thought, yeah.
So I was reading some discussion in the committee about that, but I don't know how to.
A person on the language team becomes a shepherd of an RFC, and they do this, I believe, by themselves. I don't think there's something like a secretary assigning it. I think people actually do in practice volunteer to shepherd things that they find interesting, or that they were involved in the discussion heavily of. And then after, the hope is to present, the goal is to present all the rationale for and against this feature in the RFC comments, similar to what you're doing, reach a consensus, or reach a consensus on what the advantages and disadvantages of this approach and of the other approaches are, not reach a consensus on which one is right, and then the language team ultimately makes a decision on whether that RFC is accepted or not. But it's not like a
the language team is an internal process.
Yes. Well, I mean, the thing is that they're only allowed to make a decision based on rationale already presented.
Sure.
So there isn't anything.
The voting comparison, right? Like.
Yeah, they don't
It's internal
do
to the language
voting.
team. They figure out on their own.
Yeah, I mean, they come up with an opinion, which I think in practice ends up being that they form a consensus in the language team, but the consensus is visibly formed in conversation on the thread, and then it's just accepted and it happens.
Other questions? All right, thank you.